your consideration, the Jericho.
Projectile motion. That's a lot of big words, but let us dissect what they actually mean. Okay, so the big question of the day: why does the same projectile travel different distances at different angles? And today I will be exploring this with this little Lego missile contraption. And what projectile motion is the motion of an object moving through the air while gravity acts on it. So, as we will see, the missile will move through the air upon launching. And this movement is because of two independent motions happening at the same time. We have the horizontal motion, which is constant, right? And then the force of gravity, which is accelerating it downwards at the same time. Very interesting, very interesting. And we can see that this creates a parabolic movement. So, to describe the experiment, I tested different launch angles to see how it would affect the distance traveled of the little missile here. So at lower angles, the missile moves forward quickly, but it does not stay in the air for too long. And at higher angles, so let's just rotate this here, it stays in the air, but it has more vertical force than horizontal, so it just kind of goes upward. And around like 45 degrees, which is kind of what it is right here, 45 degrees or like 135 degrees if you're going this way. That is like maximum range. It's like maximum range right there. The range equation, and this predicts the horizontal distance of the projectile. So we got R is the range, V is the launch speed, theta is the launch angle, and G is gravity. And since the force is mostly the same, the angle is like the main variable here. That affects the distance. Our next equation, we got y equals v naught y times time minus 1/2 gravity times time squared. And v0y is initial upward velocity. And this equation describes the parabolic movement, how it slows down as it's going up, and then proceeds to stop and accelerates downward. And you got your horizontal and your vertical. Horizontal describes the forward motion, and vertical describes the height, the vertical motion. Initial angle is 90 degrees, and then I increase the angle 22.5 degrees, a total of 4 times to reach the final angle of 180 degrees. And we can see at the start with 90 degrees and 112.5 degrees, it's increasing, but it's still not traveling super far. And at 135 degrees, which is the optimal angle for the most distance, we see that it goes off of the measuring device and reaches a distance of 65 centimeters. And after that, at 157.5 degrees, it decreases back down to about 27 centimeters. And then at 180, it's a bit inconsistent, but I try to keep the force the same for each flick. What have we learned? Well, we've observed that this experiment demonstrates how projectile motion depends on both horizontal motion and gravity acting vertically. By changing the launch angle of the missile, I showed that the angle affects the projectile's height, airtime, and horizontal range. The launch near 135 degrees traveled the farthest because it balanced vertical and horizontal velocity most effectively. Projectile motion, of course, used in various real-world situations like sports, football, basketball, video game physics, engineering, a lot of cool stuff, missiles and guns and things like that. And understanding this projectile motion helps explain how objects move through the air and how physics can be used to predict such motion.